Can you hear me? Everyone, can you hear me? Yes, perfect, right? Okay. Uh, I can't wait until everyone joins. That's the problem now. I was late to inform this meeting. I informed it like every week we have on Friday night, but still people need to know. Ne? That's why that's the problem. Right. Today let's do in a PDF. I guess the YouTube live is going there. Yes. Right. Let's see. You can see my screen, right, people? You can see the screen, right? Yeah. How are you, people? Now there are class students and not class students here. How are you? Doing fine, right? Right. Good. Okay, we have a new set of questions today. These questions can be directly behind the MCQ paper for sure, right? At least now we have discussed 30, 30, 30, 60, and 90 questions, including these 30. So 90 questions from inorganic we have discussed. So this is the MSQ number 4, right? Oh, no, two inorganic ones, right? MSQ 1 and 2 was from first two units, and then MSQ 3 and 4 was inorganic. So 60 questions from inorganic for now. So we'll upload two more MSQs for inorganic, and then we'll move into other units. So MSQ is not only statement question discussion, we will do theory parts in this sometimes. For example, I told you last week also electrochemistry calculations we might do, and then inorganic nomenclature we might do, organic nomenclature. Likewise, small parts are there which you can cover from MSQs. So that will be of course free of charge for everyone. So that is that. Some people ask me what is this organic thing and all. I'll show you what is this organic. I'll show the tute. Now, class students and other students, everyone, you can see the tute. Where is it? Guys ask me, that's why I'm showing. What is new? They are asking some people. What is the new thing here? There's nothing new, but like a brand new way of showing it. Wait, I'll show. I open it, right? Yeah, here you go. So we will, this is the tute number 1 actually. So you can see this part. Introduction to inversions. So that is how we start organic. So as we move on, we will move into hydrocarbons, alkanes, and look, people, there is something new here. What is the new thing here we are going to talk here? Alkanes, we are not talking production methods. Now you can see this side we are not discussing. We are discussing only this side. In every compound, we are going to discuss that side only. Because automatically when you discuss reaction part, what happens is the production part will automatically complete. So what we do is we are going to complete the total tute. We are going to complete the total tute. And you can see here the total tute. I'm saying this because you people asked. So you can see the total tute: alkynes, alkanes, benzene. See benzene. Benzene, there are a lot of theory behind benzene. So these things we have to discuss, and then stability of benzene, directors of benzene, meta directing orthopara, then this This tweet is very organized. Huh? Now here we don't have mechanisms. Mechanisms and everything is not there here. What is there is this stuff. So mechanisms is a separate tute. Variations is a separate tute. So here you go. Phenol you have, then everything you have. Here we don't talk about the production part, we are talking about only about the reaction part. And then once we complete the total tute, then we are filling out this part one by one, we are filling out this part, right? Millions and millions of conversions will be done. So every day for everyone you will get a free conversion set, like 10 questions in the group I will upload, right? So that is that. All right, let's go for MSQ now. Let's go for the MSQ. Right, the first question. First question. Copper shows a green color to flame test. Is it correct? Copper shows a green color to flame test. Now, class students, in the note, I gave only for the S-block elements. I didn't give for copper because I need to catch it through the questions. Because copper is not directly there in the syllabus. Copper is something we add externally and teachers are teaching it, school teachers are teaching it, and it could come to the LL paper. So that is why I included this question here. So copper shows a green color to flame test. That statement is correct. Actually, copper name copper 2 plus actually. Element, they are asking about the element here. Copper element shows a green color to flame test. That means copper 2 plus. It's not copper plus 1 also. We can take this as wrong also, people. We can take it as wrong also. Why? It's not copper. It is copper 2 plus. Actually, not copper plus 1 also. It is copper plus 2. You can take it as wrong also. Either way, you can take it. Right? Either way, you can take it. Then people, second one. Sodium fluoride has a positive Gibbs energy for solvation. What about that? Yeah. Talk. What about this statement? Second one. Everyone. False. It's correct, people. It's correct. It's correct means sodium fluoride has a +3. Like a +3 value, very small value. It's a very small value, but still it is positive. It has a positive Gibbs energy change. You can check the resource book as well. For this one, you can check the resource book. I'll show you the resource book if you want. This interactive session with a small amount of questions are discussed. So I'll show you the resource book. Data. In the resource book name in the tute also I have given in the tute number 3, I guess. Tute number 2, water solubility, right? I'll show in the tute to you in our tute. Wait. Inorganic. Melamine. Right here, water solubility. Under water solubility, you have this part. See, sodium fluoride. Sodium fluoride. Sodium fluoride gives energy change for solvation. You have +3 value, and that is very small value. Actually, +3 means it is insoluble. When it becomes positive, it becomes insoluble. I have discussed this in the class. So +3 value means it is insoluble, but in the syllabus we consider sodium fluoride to be soluble. So in our syllabus, what are the compounds which are insoluble in water? What are the compounds insoluble in water? Group 1. What are the 3 compounds insoluble in water? Tell me. What are the 3 compounds insoluble in water? Tell. Zoom, people. Lithium fluoride, lithium carbonate, lithium phosphate. Correct. So sodium fluoride doesn't come into that. Sodium fluoride doesn't come into this is a little bit positive, not totally positive, little bit positive, right? Okay, let's go back. Let's go back. Sodium fluoride has a positive Gibbs energy change for solvation. That is correct. Yeah. So now right, little bit thick. Yeah, isn't it coming now? It's wrong. I hate PDF people. That's why I used Word that day. Okay, sodium fluoride has a positive Gibbs engine. That one is correct. Then third one, sodium fluoride is water soluble. Correct or not? It's true. Sodium fluoride water soluble. That is correct. Now only I told you. Fourth one, beryllium carbonate is water soluble. People may first one, copper shows green color to flame test. You have to take it as wrong actually. Correct because method of copper 2 plus shows green color. Copper plus doesn't show any color. You have again they have to show it with charge actually. Copper element doesn't show any color. A copper element you hold into flame, it will form oxide. It will burn in air to form oxide. So this statement you can take it as wrong only wrong. It is only wrong. It is only wrong. First statement only wrong. Fourth one, beryllium carbonate is water soluble. This is a highlighted point in the resource book. Beryllium carbonate is water soluble. All carbonates are insoluble in water except beryllium carbonate. Right? So fourth statement correct. Wait, why isn't it coming? Oh, nice. Yeah, but in this case, now lithium has only one oxidation state. In this case, copper has two oxidation states, +1 and +2. So in that case, you can't only go for like copper shows green color because copper +1 shows another color. I mean, it doesn't show any color, yes. Copper +2 only it shows a green color. So it differs. Yeah. So we have to take it as wrong here. That is why I said you have to take it as wrong. People, what about the fifth one? Fifth statement correct or not? Good. You people are good. People, I told you beryllium, aluminum, tin, lead, zinc, right? Beryllium, aluminum, tin, lead, zinc. This is SB. SB is antimony. So fifth statement is wrong. Fifth statement wrong. Yeah, correct. Sixth one. The second most abundant element on Earth crust is silicon. Is that correct? Now, class students, right? Every week you're hearing these things. Most abundant element is oxygen, then silicon, then aluminium. Because sometimes in the structure, there's a question, people. I have faced this before, that's why I'm saying. Sometimes they give you a hint, and the only hint is the most abundant element on the Earth crust. That's all. So if you don't know that point, then you can't do the structure this way. At least like half marks gone. So make sure you know these things. Second most abundant silicon, correct. Why is that now? Sand. Sand contains what? Sand contains SiO2, right? So two oxygen atoms are there. Silicon, that's the most abundant. Then oxygen becomes the most abundant. Then comes silicon and then comes aluminium. In the resource book under aluminium, they have directly given it as the third most abundant element on the Earth crust. Third most abundant element on the Earth crust. That statement is correct. People, the seventh one. What about the seventh one? Aluminium chloride can undergo dimerization at liquid state. Make a last week I gave in another form. This week I'm giving in another form. Can you tell me the answer now? Last week some of the people got it wrong. That's why I included here. Aluminum chloride can undergo dimerization at liquid state. Today also you're getting it wrong. It can dimerize at solid, liquid, and gas state, all three states. Now in the resource book, they have told gaseous state, but the thing is in the past papers I told you last week, they have taken aluminum chloride can undergo dimerization in solids, they have taken it as correct. In liquid, they have taken it as correct. Gas also correct. So we now consider dimerization happens in any state Like that is, we consider it like not asking syllabus. But if they said like gaseous state, then definitely it is dimerizing, because resource book also they have directly given it as dimerizing in gaseous state. However, it should be anhydrous. Huh? If there is water, aluminum chloride will react with water to form that complex name, aluminum water complex, that one. So it should be correct. This statement is correct. Eighth one, CO2 is used as a freezing agent. Correct or not? It's a resource book statement. It's theory part, normal theory part. Carbon dioxide is used as a freezing agent. I gave this in the tutor also. These things people can come. These are the new question patterns. You can see the past papers. You can see 2024 paper. These are the new question pattern. This is the new question patterns, right? Carbon dioxide is used as a freezing agent. That is correct. Now, use of hydrogen to make margarine. Who will expect that it could come? Ninth one, decomposition of any ammonium salts give ammonia. Correct or not? Don't say true. Why? There are three exceptions. Ammonium nitrite, ammonium nitrate, ammonium dichromate, they do not give ammonia. What they give is ammonium nitrite will give N2, ammonium nitrate will give N2O, and ammonium dichromate will give N2. How do you remember this? You have to take as much as water out of the molecule. So what is remaining is the compound which you are getting. So this statement is wrong. 10th one. Addition of nitrite into water gives you ammonia gas and strong base. What about that? Huh? What about that? People? True. Addition of nitrite into water gives you ammonia gas and strong base. Is it correct? Everyone? Go. Tell. Sleeping. Ayyo, තාම කීයද වෙලා? What is the time? 10:30 men. Be active. Come on. Come on, be active. Go kattiya. Wake up. Lithium hydroxide is a strong base. S-block bases are strong bases. According to our syllabus. Tulasika, Rushda, Priyanka, where are you? Where's Gavya and all? Talk, man. Your class students' name? Right. 10th, addition of nitrate gives ammonia and strong base. That is correct, people. It's direct theory point. Hurry. We have done 10 questions now. How many of you got more than 8? How many of you got more than 8? Huh? Now 10 questions done. More than 8. How many correct? How much? How much correct? Exactly 8 you got. 9, 7, 8. 2 8s are there and 3 8s are there. 10 out of 10 is also there. Nice. 7. Good. So once you complete all the 30 questions, make sure you pass 25 at least. Let's see. So next 10 questions, I'll go into the next 10 questions. I'll clear these. Okay, 11th one. 11th one, see, will you? Ammonia can act as an acid. Is it correct? Easy, theory point. Ammonia can act as acid. True. Ammonia can act as oxidizing agent, act as reducing agent, act as an acid, and act as this. So ammonia acting as an acid, we reacted it with the S-block element. Can you remember that? We reacted it with the S-block element. Ammonia plus sodium, you get sodium amide and hydrogen gas. So likewise, acidic nature means you have to react with a base, and metals like sodium are bases. So ammonia can act as an acid. That statement is correct. 12th one. In the reaction where ammonia acts as an oxidizing agent, nitrogen atom will be reduced. Correct or not? Ammonia acting as an oxidizing agent, nitrogen atom will be reduced. Correct or not? Huh? Go tell. Correct or not? True. Why is it true? Huh? Ammonia acting as an oxidizing agent undergoes reduction, right? Ammonia acting as an oxidizing agent, what did he do? We always reacted with the S block element. So ammonia plus sodium, we can take it as an example. Here, I'll write it. Ammonia plus sodium. Ammonia plus sodium goes to NaNH2 plus H2. NaNH2 plus H2 gas. People, here nitrogen, look here -3, here also -3. It doesn't change. It is unchanged. What is changing then? Okay, sodium goes to plus from 0 to +1. But here hydrogen, it is +1 here. It will go to 0 here. That's the change. That's the difference. That's the difference. Hydrogen, now ammonia, you might think only nitrogen can undergo oxidation number changes. But here you can see hydrogen has undergone oxidation. Oxidation means reduction. And sodium has undergone oxidation. So ammonia acting as oxidizing agent, hydrogen atom will be reduced. Hydrogen atom will be reduced. So people, nitrogen cannot further undergo reduction. And nitrogen is in -3, it cannot further undergo reduction. So always what is going to happen is hydrogen will undergo reduction. Right. Then false. 13th one. NCl3 when added to water gives a strong acid and a bleaching agent. NCl3 when added to water gives a strong acid and a bleaching agent. Strong acid and a bleaching agent. Correct or not? False. It gives ammonia. It gives ammonia and a bleaching agent, not strong acid. It doesn't give HNO3 or anything. It gives what? What does it give? Ammonia and HOCl. Correct. So this statement wrong. SiO2 is a neutral compound. What about that? False. SiO2 is acidic. SiO2 is acidic. So that's a theory point. This one also wrong. 15th one. Fe2 plus will be oxidized to Fe3 plus upon addition of concentrated sulfuric acid. What about that? Theory point. Theory point. Theory point. Theory point. Theory point. People, come on. You're too late. You're too late. Right, quickly. Vinsha, are you coming to my revision? Vinsha, I can't remember your name. No, right? Fe2 plus will be oxidized to Fe3 plus upon addition of concentrated sulfuric. This was a special point we discussed. Now, Fe2 plus to Fe3 plus, even atmospheric air can do it. We talked about that. But this concentrated sulfuric cannot do it. Actually, Fe2 plus, when added to concentrated sulfuric, even atmospheric air will not be allowed to oxidize. That means what? Fe2 plus when added to concentrated H2SO. Concentrated H2SO doesn't oxidize Fe2 plus, and also it doesn't allow the atmospheric air to oxidize. So it's like preventing from oxidation. So this one is a highlighted point which could come to this year. This is 15th question. MCQ. It could come. I'm just saying, make sure you study this. Make a danagin in the 15th question. Just know it. I'm just giving you a warning. So Fe2 plus will be oxidized to Fe3 plus. That is wrong. HNO3 can do it, people. HNO3 reacting with Fe2 plus, it will go to Fe3 plus. There was a nice note given for this. We talked about HNO3 7 reactions, H2SO4 7 reactions. That is how we went. There was 16th one. When N2O3 is added to water, it will give a strong acid. What about that? N2O3 added to water, it will. What about that? What are the oxides you have? N2O, NO, NO2, N2O3, N2O3. I have to buy a writing pad. Now it's time to buy a writing pad, right? Ah, no, before this one you have that. Can I move this? New feature unlocked. Oh, you can't go that side. I want to select all. How do I select all? Ayo, useless features, people. Here you go, N2O3, and then you have NO2. I'm writing very hardly now these things. N2O5. You need a special skill to write it like this even. Hurry. N2O when added to water, nothing will happen. You know that both N2O and NO, no reaction will happen. We talked about only these three. All of these, now let's say N2O3 when added to water, it will form HNO2. HNO2 is not a strong acid. When N2O5 is added to water, it will form HNO3. It will form HNO3. When NO2 is added to water, it will give a mixture of two compounds. It will give HNO3. It will give HNO3 and NO. This is a new syllabus one. All syllabus you had HNO2 plus HNO3. Now you have NO and HNO3. This part we talked about in the class, right? So here you go. N2O3 cannot produce a strong acid. It cannot produce a strong acid. Right. So. That statement is wrong. Water is amphiprotic. What is amphiprotic? What is the meaning of amphiprotic? Everyone? What does it mean by amphiprotic? Amphiprotic means what? It is same like amphoteric people. Amphiprotic means ability to gain a proton and ability to release a proton. Water can do both. Yeah, it can accept a proton and release a proton. That is known as amphiprotic. Water is amphiprotic. That is correct. Nitric acid is a viscous liquid. There are two viscous liquids in our syllabus. H2O2 and HNO3 are the two liquids, viscous liquids in the syllabus. So you have to consider that one here. So this statement is correct. 19th one, reaction of PBS with hydrogen peroxide turns PBS to yellow color. What about that? What is the color of PBS? First tell me what is the color of PBS? Color of PBS. Color of PBS. Lead sulfide color. Black color ne? Melissa, right? Melissa. So Melissa, mercury, lead, and silver. Right? Melissa. Silver namine. මොකද්ද මම කට්ටිය කිව්වේ? ළමයි? Melissa belongs to first one, right? That is the first one. Then second one you had Lonely Biscuit could hug me. Lonely Biscuit could hug. And then 4 lemon tins are there. ඒ වගේ එකක් කතා කරන්නේ ක්ලාස් එකේදී. There you had a lead 2 plus sulfide නේද? So that is black in color නේද? Lonely Biscuit could hug. Lonely, right? Lonely. Lead 2 plus lead sulfide you had. Lonely Biscuit could hug that part. It is black in color. Then it will go to somewhat yellow color. Now H2O2 and lead sulfide reaction was highlighted in the note. So this will form lead sulfate, PbSO4, which is white in color. So this statement is wrong. 20th one. Nitrogen cannot behave as an oxidizing agent. Nitrogen cannot behave as an oxidizing agent. What about that? Tell me. What about that? Everyone talk. Talk. Everyone talk. Ah. Nitrogen can act as an oxidizing agent. One example is reacting nitrogen with a S-block metal like lithium. Let's take lithium plus nitrogen, it will form lithium nitride. So in that lithium nitride, you will get lithium goes to lithium plus, that is oxidation, and nitrogen will go from 0 to -3. Uh, which one you're telling? NO2 in sunlight gives NO2 in sunlight gives atomic oxygen? No. N2 cannot act as oxidizing agent, that is correct. Cannot name can false. Can. 21st, CrO3 dissolves in aqueous NaOH solution to form Cr2O7 2-. What about that? What about that? False. Why? It is CrO4 CrO4 2-. So this statement is wrong. Right. 21 questions done. 22nd done. Beryllium reacts with hydrogen to form ionic metal hydride. False. It is a covalent metal hydride, people. Now we don't consider beryllium to react with hydrogen. In the old syllabus only we consider beryllium to react with hydrogen. The new syllabus we take it like beryllium does not react with hydrogen, because in the resource book they have not given anything about beryllium. So this reacts with hydrogen part is like very confusing now. It is not directly given in the resource book, and also it's like a questionable part. So this one was taken from 2024 A-level paper. 22nd question, this one was given from an MCQ statement. This is an MCQ statement. So it's a solid covalent metal hydride. If you think like that and route an answer, then also you're correct. If you think like beryllium does not react with hydrogen, then also you're correct. So this statement is wrong. 23rd one, people. Sodium and barium react with excess oxygen to form Na2O2 and BaO2. Bauxite. BaO2 is barium peroxide. I told you this. Suffering, come on. Suffering, check your notes. We drew the structure of peroxide. And then we put barium 2 plus into it. This one is correct. My friends got it wrong. Huh? This barium oxide, some of my friends got it wrong. Like not normal friends, they are like very studying friends. I mean, studying friends can be clever ones. Anyone it can happen in the A-level paper, so be careful about these things. Some people think it is like peroxide is always like Ba2O2. These are group 2 compounds, so +2 oxidation state. So BaO2, it is correct. 24th one, people. Ammonia, H2S and SO2 can act as oxidizing agent as well as reducing agent. Is that correct? It is true. It can act as oxidizing agent as well as reducing agent. Magnesium has highest electronegativity among S-block elements. What about that? This one also taken from 2024 A-level paper. 25th one. What is it? False. Why? Who's the largest one? Who has the largest? Hydrogen, Alma somewhere. Now the thing is, hydrogen you can't take it into an S-block element. Hydrogen belongs to nowhere, people. It's like a lost element. You can't put hydrogen anywhere. It has properties of group 17 ones also. It has properties of S-block also. So hydrogen you can't take to anywhere. It's like somewhere else. Beryllium is the answer. Beryllium is the most homeless hydrogen. Magnesium has that is wrong. It is beryllium. Carbon cannot undergo oxidation. If you get this wrong, don't do chemistry. Huh? Carbon cannot undergo oxidation false. Right? Carbon can go to carbon dioxide. Yeah, that one also can. Carbon cannot undergo oxidation, not C2O4 to carbon dioxide. Carbon to carbon dioxide, we discussed this. Carbon goes to carbon dioxide. We discussed this, right? Under HNO3 and H2SO4, we discussed it. So this statement is carbon cannot undergo oxidation. That is wrong. 26 questions done. 4 questions left. Let's see next part. Why did I erase that? 27th one. HNO3 reacts with sulfur to form SO2, HNO3 and H2O. Reacts with sulfur. If they say reacts with sulfur, they are reacting in normal conditions. Huh? Is it correct or not now? It is true. Under vigorous conditions, HNO3 with sulfur, it will form H2SO4 and NO2 and H2O. This product, this SO2, this is only under normal conditions. So under vigorous conditions, that means if you heat the solution, you will get H2SO4. H2SO4, NO2 and H2O. So this statement you can take it as correct. If they say under vigorous conditions, then this statement is wrong. Under vigorous conditions, it will form H2SO4 people. It will form H2SO4. 28th one. Aluminium reacts with oxygen to form oxide, which reacts with both bases and acids. What about that? Aluminium reacts with oxygen to form oxide, which reacts with both bases and acids. That is correct. Aluminium, when reacted with oxygen, it will form Al2O3. Al2O3 can react with acids and bases. So when the element is amphoteric, the oxides are also amphoteric. So 28th statement correct. 29th one. Wet litmus paper, blue in color, can be used to distinguish SO2 and carbon dioxide. What do you say about that? Wet litmus paper blue in color can be used to distinguish SO2 and CO2. Is it? All of you are saying wrong. You don't know about sulfur dioxide still. All of you, like not even single person said true. Not even single person said the statement is true. All of you are wrong. Wet litmus paper, blue in color. Okay, SO2 and carbon dioxide are acidic. It will turn blue litmus to red color. Both of these can do it. When SO2 is exposed to wet litmus, what happens is first it will turn blue to red. That's the first thing. Blue to red, both will convert. And SO2, what happens is it will undergo bleaching. The wet litmus paper, it will undergo bleaching and it will turn like colorless. It will turn like white in color. It fades its color and it like bleach, you know, bleaching. It will undergo bleaching. So you can distinguish SO2 and CO2 from this. You have to take it as correct. Make sure you have here wet litmus paper. Wet litmus paper should be there. To undergo bleaching, you should have a moistened wet litmus paper, like moistened flower petal. Now, SO2 identification, moistened flower petals. It should contain water. Right. 29th statement, all of you are wrong. 30th one. Ag2O reacts with ammonia to form nitride. What about that? Ag2O reacts with ammonia to form nitride. Dry one can't be used. I mean, dry one can't be used means like SO2, it will not undergo bleaching if it is dry. Ag2O reacts with ammonia to form nitride. True, the no. Look at the ammonia's reactions under reducing agent, acting as a reducing agent. Last part. Acting as a reducing agent, we discussed in 3 parts. First one with oxygen, second one with chlorine, third one with Ag2O and CuO. So they are reacting with Ag2O, it will form silver and then nitrogen gas. So this statement is wrong. 30 questions done. How much did you get? Huh? 30 questions done. How much did you get? 22, 27. Others 22. 25, 25, 24, 28. Now class students have upper hand because we have discussed these things in class. Like මේවා තමයි අහන්නේ, මේවා තමයි notes වල තියෙන්නේ. So they have an added advantage here. Bushra sign up 28, good. Anyone more than 28? Anyone more than 28? බොරුල් කියන්න නම් එපා. Don't tell lies. Huh? Tell me the truth. Right. That's it, people. Today's MSQ we have completed, and next week also you will get something like this. People, next week is March first week. You will face March first week next week. So next week also belong to February. So after that only the month of March begins. Month of March begins means exciting. We are starting organic, we are starting gases, and then we are starting energetics. So energetics might not be started actually, like we have to drag gases and we have to do a lot of questions. So it will take time, and time will lead to like finish the month by just organic and gases. So by that time we will, now next month we are also starting the paper class. So paper class, I'll tell you the details. Special meeting, Monday special meeting you have. AKT, I'll tell you how to balance A-level paper, chemistry paper. Likewise, we can talk about that. Right, people, then you can leave the meeting now. It is 10:50 now. Have a good night, and you can study now until 1 or 2, maybe. At least sleep for 5 hours. Right. You can leave now. Bye-bye.